Hello, hi everyone. Welcome to the Student the Brand. So myself, I am Siva sir. Today we are going to discuss about light reflection and refraction. Light reflection and refraction. Hello everyone. Welcome to the class. Join to the class. So in this class we are going to discuss about light reflection and diffraction chapter. I hope in the previous class we discussed. I hope in the previous class we discussed light reflection phenomena. Right, reflection phenomena. Hi, welcome to the class. So in the previous class, as you see, so you can observe in the previous class. What's up? Nothing. So we are discussing light reflection and diffraction chapter, physics, grade 10 CBSE. Myself, I'm Siva sir. You're a teacher. Yeah, of course, I'm a teacher. I'm studying in Simla. Okay, which class you are studying? Which grade? Which grade you are studying? Oh, nice. Very nice. Motion, force and laws of motion, gravitation, sound. Keep on teaching. Gravitation. So, sound chapter is there. Gravitation is there in our ninth class. Oh, thank you. पढ़ लो चाहिए सिलेक्शन होगा यूथ कॉन्सेप्ट चमकायन पड़ेगा फिजिक्स वाला so someone in the name of alakh pandey so came. So please if you are typing, please type in English. थोड़ा हिंदी फिजिक्स वाला. Sir, are you really alakh pandey sir? Yeah, physics wala, yes. Yeah, I'm great fan of you, sir. If physics wala means. No, I'm not getting, sir. Actually, if you are, please type in English if it is possible. Not real. What are you trying to do? Yes, he is just being humble. I think. Sir, great work. Technology is really making concept easier for students, so use it wisely, sir. Sir, you teach good, sir. Thank you. Sir, are you studying or doing something else? I am teaching. My studies completed. I am working. Thank you, sir. So, in the name of Alakh Pandey, someone came. So, it's really Alakh Pandey, sir. I want to know, sir, what you are wearing? Someone name he kept. Okay. Yeah. Myopia, myopia, myopia. Myopia, myopia, myopia. Near distance we can see ya. Far distance we can see ya. Myopia, myopia, myopia. Myopia, myopia, myopia. For that correction we are using concave lens, concave lens, concave lens, concave lens. New Cartesian sign convention, new Cartesian sign convention. All the distance measure from the pole. Distance are positive along the incident trace. Distance are negative opposite to incident trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. So, welcome to the class, everybody. Welcome to the class. Myself, I am Siva sir. Today we are discussing light reflection and refraction chapter. Light reflection and refraction chapter. So, already we discussed in the morning class. I explained about light reflection chapter. I hope almost sign mirror image formations completed. You can see on the screen. So this until here I completed in the morning class, around 11 a.m. So I completed this one. Now we are going to discuss about refraction. Come on, refraction topic will discuss refraction. So here I'm considering. So hi everyone, welcome to the class. Welcome to the class. So refraction is nothing but refraction. Refraction is nothing but when light is passing from one medium to another medium. When the light is passing from one medium to another medium, so the path of the light changes at the path of the light changes, the direction of the light changes at the interference of the two media. At the interference of the two media, the path of the light changes, so the direction of the light changes at the interference. So hi Sivani, have you wrote the exam? How it is? So you said today exam. How you wrote? Is it good? Any problem? Any concerns? Sir, my exam is good. Very good, very good. So nice, good job. So refraction. Refraction. Refraction is nothing but so I'm taking, so here I'm considering this is a rarer medium, denser medium, denser medium. If the light ray is passing from one medium to another medium, so physics I have one question. Okay, tell me. So hello, hi everyone. So its radius is half, the length remains same. How it will be affect resistance? Radius is half, length remains same. Area of the cross section, right? Area of the cross section. So here we can take R equal to rho into L by A. So length they are taking same. So here pi R square we are considering. Pi R square. So here they given, so R2 equal to R by 2. Radius is half. So you can substitute and find out the values. So here 1 by pi R square 1 by 4. So 4 times. So 1 by 4 is nothing but R by 2 will get. 4 times it will increases like that. Like that. So you can use this formula. Pi R square, right? In the process, in the A, we have to substitute. 1 by 4. Sir, it will be 1 by 4. No. Actually, R equal to rho into L by pi R square. Generally, R square. So if you are taking rho into L by pi into R by 2 whole square. So already it is named out. So we have to cross multiply. So L by 2 pi R square. So into 2 by 1. 2 by 1. So like that we have to take. Okay, na? So that is whole square, right? Anyway, it is half square, 4 you will get. 4 times of resistance. And then you can take, this is the, okay. So if it is on that case, 1 by 4, okay. So instead of taking that one, if you are substituting R value, R2, so R2 equal to rho into L by pi R square by 4. Okay, so this entire thing, if you are taking R by 4, correct. R by 4 is correct. If you this entire thing, if you are taking, so you can take it. If you entire thing, if you are taking R by 4 you will get. Okay, done. Okay. No. So this we have to follow. So if you are taking these values are, so then we can get the answer. Okay, so okay, Vaibhav, we'll discuss that one. So we'll come to the point. So refraction, I'm telling refraction, when the light ray is passing from one medium to another medium. So I'm taking here. So if you are considering like this, so rarer to denser, it bends towards the normal line. So it bends towards the normal line. So the angle between incident ray and normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. Angle of refraction. Okay. So this is the incident ray, refracted ray. This is the normal line. So this also normal line. N and N dash we are considering. when the light ray is passing from one medium to another medium, the light ray is passing from one medium to another medium, so at the point of interference, the light ray will bend. At the point of interference, the light ray will bend. So that is called refraction. Refraction we are considering refraction. Refraction. The bending of the light at interference of the two media is called refraction. So if the light ray is passing from rarer to denser, if the light ray is passing from rarer to denser, if the light ray passing from rarer to denser, if the light ray is passing from rarer to denser, so angle of refraction is greater than, angle of refraction is less, because angle will decrease, right? Angle will decrease. So angle of refraction is less than the angle of incidence, because this angle is greater. So when it is moving from rarer to denser, it bends towards the normal line. So the angle between normal line and refracted is called angle of refraction. Here angle of incidence. So angle of incidence is greater than the angle of refraction. So that is about a refraction phenomena. Okay. So at the same thing, if the light ray is passing from, so if you are considering this the rarer medium and denser medium, if the light ray is passing from denser to rarer, it moves away from the normal line. So this angle of incidence and angle of refraction. In this case, angle of refraction is greater than the angle of incident. Angle of refraction is greater than the angle of incident. Angle of incident is equal to angle of emergence. That is in glass slab. Okay, so when the light ray passing through glass slab, that time we can consider. So now we are considering if the light ray is passing from denser to rarer, it moves away from the normal line. If the light ray passing from rarer to denser, it bends towards the normal line. Okay, so the path of the light changes at the interference of the two media. So the path of the light changes at the interference of the two media is called refraction. The path of the light changes at the interference of the two media is called refraction. Refraction of light is nothing but at the interference of the two media, the path of the light changes. That is nothing but, so refraction of light. So here rarer medium and denser medium. Rarer medium, if you are considering, rarer medium is the speed of light is more in the medium, that is called rarer medium. Speed of light is less in the medium, that is called denser medium. So if it is passing from rarer to denser, it bends towards the normal line. If it is passing from denser to rarer, it moves away from the normal line. So this is about refraction. And the conditions for no refraction. So if the light ray passes along the normal line, if the light ray passes along the normal line, so light ray passes, so I'm taking light ray passes along the normal. Conditions for no refraction. When no refraction takes refraction, so light ray passes along the normal line, then that time refraction takes place. Light ray passes along the normal line. So if you are taking light ray, so in this direction, if the light ray passes along the normal line, no refraction takes place. And second one, so the refractive index of the two media will be same. That time no refraction takes place. That time also no refraction takes place. Okay, so that is for no refraction. And coming to the laws of refraction. There are few points are there related to this topic. Laws of refraction. So when the light ray is passing from rarer to denser, it bends towards the normal line. When the light ray is passing from rarer to denser, it bends towards the normal line. So I'm considering here. So here I'm taking the surface. So the light is incidenting on it. So I'm taking this normal line. The light ray bends towards the normal line. So this is the angle of incidence and angle of refraction. Angle of incident and angle of refraction. So here I'm considering the ratio of, so angle of incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. First point is incident ray, refracted ray, normal line. Lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. And one more point. So second one you are taking. Second one. So sine of angle of incidence to sine of angle of incidence to sine of angle of refraction equal to sine of angle of incident to sine of angle of refraction equal to constant. Sine of angle of incident to sine of angle of refraction equal to constant. Sine of angle of incident to sine of angle of refraction equal to constant. So that is also known as Snell's law. That is also known as Snell's law. So that constant is nothing but refractive index. 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 Refractive index is nothing but the ratio of sine of angle of incident to sine of angle of refraction. The ratio of sine of angle of incident to sine of angle of refraction. So that is nothing but refractive index. So here refractive index we can consider n equal to c by v. N equal to c by v. N equal to c by v. What is c? Speed of light in vacuum. What is v? Speed of light in vacuum. What is v? Speed of light in medium. So what is c? Speed of light in vacuum. So what is v? Speed of light in medium. Speed of light in medium. Speed of light in medium. So the ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. The ratio of speed of light in vacuum by speed of light in medium. The ratio of speed of light in vacuum by speed of light in medium. The ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. Coming to relative refractive index. Relative refractive index n to 1. If you are taking either in this format we can write, or we can write in this n2 by n1 we can write, that is nothing but so v1 by v2. So v1 by so here we can take from this, so n is inversely proportional to velocity. Refractive index is inversely proportional to velocity. So from that, so the representation method is very important. Representing, how you are representing, that is very important. So which degree you have? Huh? So here you can see this is my biodata. So student Brand, 10 years experience in physics teaching, Siva sir, mechanical, BTech mechanical. Okay, so this is my biodata. If you want any other details, you can call to this number or you can WhatsApp to this number. So 98498120804, right? Okay, come to the point. Next one. So n21 if you are taking n21 equal to n21 or n12, n21 equal to n2 by n1, that is nothing but v1 by v2. So v1 by v2. So here we can observe one thing. Okay, so refractive index is inversely proportional to velocity. So refractive index is inversely proportional to velocity. Then so n is inversely proportional to velocity you are considering. Okay, so we can take n2 by n1 equal to v1 by v2, n2 by n1 equal to v1 by v2. So I hope it is very clear. So next one, we are going to the next point is refractive index is very important. Speed of light in vacuum by speed of light in medium. So that is according to the direction if you take, so that is velocity. Only the difference between speed and velocity is the direction. So that's why we are taking. So here we are considering speed only. So speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium. So relative refractive index is nothing but so speed of light in medium 1 by speed of light in medium 2. So with respect to we are considering with respect to what medium will consider, based on that one we can take refractive index. So based on refractive index we'll do problems. Now I am going to the glass lab. Refraction through glass lab. I'll explain about refraction through glass lab. So now I can consider refraction through glass lab. Refraction through. So this question is very important. Refraction through glass lab. Glass lab. Okay, so this question is very important. 3 marks question will come. So in the previous board exam, if you observe, this question is given. Okay, refraction through glass lab. So when the light falls on it, so refraction we can draw now. I'm drawing, so I'm taking the glass lab here. This is a glass slab. Okay, so incident ray, this incident ray I'm taking. Incident ray. So the light which is incidenting on the surface, this is the incident ray. The normal I'm taking, this is a normal line. Normal line I'm taking. So the light which is refracting, so it is refracting through the surface. So and again we are considering, so here it is emerging out. It is emerging out. It is emerging out. So now here it is now this angle of incident. In this case only we can take angle of incident equal to angle of emergence. So now you can observe. Now we can observe here. So now the angle, this is the angle of incidence and angle of refraction and angle of emergence. Angle of emergence. So incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line. So in this case, so if you are extending this incident ray, if you are extending this incident ray, so that will become parallel to the emergent ray. So extending incident ray. So initial direction of the incident ray. So if there is no surface, the light ray passes in this direction. So the distance between emergent ray and extended incident ray is called lateral shift. Lateral shift. Sorry, initial direction of the incident ray also we can say. The distance between emergent ray and the distance between emergent ray and initial direction of the incident ray or incident ray direction, the distance between the perpendicular distance, the vertical distance between emergent ray and initial direction of the incident ray, okay, done. So now you are going to the next one. So here you can consider, so the distance, the vertical distance between emergent ray and extended incident ray, is called lateral shift. So very important. And vertical shift also there. So vertical shift also there, that we will discuss later. Okay, one by one we are discussing. So here incident ray, refracted ray, emergent ray. 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 So I am considering incident ray, refracted ray and emergent ray. Incident ray, refracted ray, emergent ray. Okay. So what are we are discussing in this concept? So this point is very important. That is lateral shift. Lateral shift is very important. So keep in mind angle of incident and angle of refraction and angle of emergency. And one more thing, vertical shift. If you are taking a beaker, like this, so I am considering the beaker. So you place the coin at the bottom of the beaker. So if you place the coin at the bottom of the beaker, so you are standing here. If you see the coin, you can't able to see. So when you are seeing the coin, you can't able to see. After pouring water, if you pour the water, then the coin position appears to be raised. So the position of the coin appears here. Actually, this is the apparent position of the coin. And this one is the actual position of the coin. So this is the actual position of the coin. So the vertical distance between apparent position to actual position is called vertical shift. Vertical shift is nothing but the vertical distance between actual position to apparent position. Actual position to apparent position is called vertical shift. The distance between actual position to apparent position is called vertical shift. So related to refraction, 3 questions will come in exam. 3 marks question. 3 questions will come. First question is, so lemon placed in the water tumbler. So and pencil placed in the water tumbler, it appears to be bent. And the third one, coin placed. So these 3 questions will come in the exam. So among these 3 questions, 1 question will come in exam. That much important. That much important. So make sure that you are preparing this question. Lemon placed in the water tumbler appears to be big. So pencil placed. So pencil. So I'm placing the pencil here. I'm placing the pencil. Water is here. Water is here. If you are taking the pencil like this, so at this position, at this position of water and surface, the pencil appears to be bent. The pencil appears to be bent. So the pencil appears here. The pencil position appears here. Generally, the position pencil is like this only, but so because of the refraction, so at this point it appears to be bent. So so the bending of, as I said, bending of the light at the interference of the two media is called refraction. So the light ray will bend at the interference of the two media. Okay, so that's why you can see. Okay, na? So that's why it is appearing here. It appears to be bent. Even in gas tumbler also, if you place the lemon, it appears to be bigger. If you see the in shops, so if you go to that, so they'll place lemon inside of the water tumbler. So water tumbler, it appears to be bigger. Because of because of refraction. And coin placed. So coin position also rises up. So these three questions, so they will give for 3 marks. They will give for each question. Each question they may give for 3 marks. Very, very important. So learn it. So when the pencil is placed at the interference between water and air, said that position it appears to be bent. So at this position it appears to be bent. When you are weaving through it, it appears to be bent. So we can observe the pencil is appears to be bent. Okay, na? And here, and one more thing. So the vertical distance between coin actual position, vertical distance between actual position to apparent position of the coin. So the vertical distance between actual position to apparent position of the coin is called vertical shift. So very, very important. Make sure that so you are learning this one. Very, very important concept. Then we are going to the next one. If you like this video, please do like, share, and subscribe to Student the Brand. You can subscribe for more updates regarding the live classes, post, anything. So do like, share, and subscribe to Student the Brand. Okay, next one, we are going to the next one. Refraction completed. Refraction through glass slab is completed. Next one, we will discuss about refractive index. Actually, based on refractive index, we have to do problems. We have to do problems related to refractive index. So related to refractive index, we have to do problems. So we will work out on lenses, ray rules and image formations. We'll discuss now. So if you are taking lens, convex lens, first one I am taking the convex lens, ray rules of convex lens, ray rules of convex lens. Ray rules of convex lens. So first one I am taking the lens. First lens, convex lens. Optic center F1, 2F1, F2, 2F2. So one light trace, I am taking the light trace like this. So object is at infinity. So object is at infinity. So here we can say object is at infinity. So light rays will come coming parallel to the principal axis. Light rays are coming parallel to the principal axis. After the refraction, those light rays will meet at one point on the principal axis. So after refraction, light rays will meet at one point on the principal axis. Now you can see, so here, so after refraction, the light rays are meeting at one point here. Okay, so image will form at F2. Image will form at F2. Nature of the image is real, inverted, and highly diminished. Real and inverted and highly diminished. Point one. Second to the second one, so if you are taking the second lens, optic center F1, 2F1, F2, 2F2, F2, 2F2. So object is placed beyond center of curvature. Ray rules we are discussing about ray rules, right? So ray rules, these are the image formations. Whatever we are discussing, diminished. Okay, so anyway, three ray rules are there. Three ray rules. First one. So I'm taking optic center F1, 2F1, 2F1, F2, 2F2. So one light I'm taking it after refraction, it passes through focus. After that, it passes through focus. First one. So second one, if the light ray passing through the focus F1, 2F1, F2, 2F2. So if the light ray passing through focus, after refraction become parallel to the principal axis. And third one, if the light ray passing through optic center F1, optic center F1, 2F1, F2, 2F2. Okay. So if the light ray passing through optic center, so no deviation takes place. It passes like this. So these are the three ray rules. These are the three ray rules. Okay. So three ray rules. So next one we are going to the concave lens. This is a concave lens. Concave lens. I am taking this a concave lens. Optic center F1, 2F1, F2, 2F2. So same, if the light ray coming parallel to the principal axis after refraction, so it will move away. So if you are extending, it passes through the focus. And the second ray I am taking here, second ray I am considering here. So if it is passes through focus, optic center F1, 2F1, F2, 2F2. If the light ray passes through focus, after refraction become parallel to the principal axis passing through focus. And the last case, last ray rule is for a concave lens. If the light ray passes through optic center F1, 2F1, F2, F2, 2F2. If the light ray passes through optic center, no deviation takes place. Okay, so it passes like that only. Okay, so I hope it is clear to you all. So I hope it is very clear to you all. So this about ray rules. Ray rules of convex lens and concave lens. Ray rules of convex lens and concave lens. Next one we are going to the image formations. Image formation. Here you can see after light rays become parallel. After that, after refraction, the light rays will meet at F2. So object is placed beyond 2F2, 2F1. One light ray I am taking like this. It passes through focus. Passes through focus. Another light ray I am taking. Another light ray I am taking through optic center. So those will meet beyond. So beyond 2F2. So beyond 2F2, image will form here. Image will form here. Okay, so image will form here, like here. Okay, object is placed beyond 2F1. Beyond 2F1, image will form. Object is placed beyond 2F1. So image will form. Image will form. Image will form between Image will form between F2 and 2F2. So nature of the image is real and inverted. Size of the image is diminished. Size of the image is diminished. So next one, third one. So I'm taking third image formations. So object is placed. This is the F1, 2F1, F2, 2F2. So object is placed at 2F1. One light I am taking like this. It passes through focus. So another light is passing through optic center. So those will meet between. So object is formed. Object is placed at 2F1. Image will form at 2F2. Nature of the image is real and inverted. Nature of the image is real and inverted. Nature of the image is real and inverted. Real and inverted. Size of the image is same size. Size of the image is same size. Coming to the fourth one. So I'm taking like here. So like this. So optic center. So F1, 2F1, F2, 2F2. So object is placed between 2F1 and F1. Now image will form beyond 2F2. So previously I do right. So that diagram here I do. So it should form beyond. So now if you place between 2F1 and F1 only, the image form beyond 2F2. Okay, now so you have to remember that one. So the image will form here. Object is placed between 2F1. Image will form beyond 2F2. Beyond 2F2. Nature of the image is real and inverted. Nature of the image is real and inverted. Size of the image is enlarged. Nature of the image is real and inverted and size of the image is enlarged. Nature of the image is real and inverted. Size of the image is enlarged. So keep in mind that one. So nature of the image is real and inverted. Size of the image is enlarged. Okay, so once again, so we'll discuss all the points. So listen carefully. Listen carefully. So whatever I'm discussing, all the points, once again we will discuss. So here, in this case, object is at infinity. Object is at infinity. Image will form at F1, F2. Image will form at F2. Object is at infinity. Image will form at F2. What is the nature of the image? Real and inverted. Nature of the image is real and inverted. And size of the image is highly diminished. Size of the image is highly diminished because point size image will form at F2. So point size image will form at F2. Next one, object is placed beyond 2F1. So beyond 2F1 here, image will form between F2 and 2F2. F2 and 2F2. So nature of the image is real and inverted and size of the image is diminished. 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 So object is placed at 2F1. Image will form at 2F2. Object is placed at 2F1. Image will form at 2F2. So nature of the image is real and inverted. Same size. Real and inverted. Same size. Real and inverted. Same size. Real and inverted, 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 real and inverted, real and inverted, real and inverted. So why we are giving background music for this one? Because if the object is placed at C, image also will form at C. So like if the object is placed as 2f1, image will form at 2f2. So nature of the image is real and inverted and same size. Very very important. Very very important. So very very important. Very very important. Very very important. Next one. Next one we are going to the next one. Next one. So next one, object is placed between 2f1 and f1. Object is placed between 2f1 and f1. Object is placed between 2f1 and f1. Image will form beyond 2f2. Image will form beyond f2. Image will form beyond 2f2. Object is placed between 2f1 and f1. Object is placed between 2f1 and f1. Image will form beyond 2f2. Image will form beyond 2f2. What is the nature of the image? Real, inverted and enlarge, real inverted and enlarge, real inverted and enlarge, real inverted and enlarge. Object is placed between 2f1 and f1. Image will form beyond 2f2. What is the nature of the image? Real inverted and enlarge, real inverted and enlarge. So now we are going to the next one. So object is placed at f. So in this case, object is placed at f1. We have to discuss. Object is placed at f1. Now you can see. So fifth one. So if the object is placed at f1, image will form at infinity. Object is placed at f1, image will form at infinity. So nature of the image is real and inverted, and size of the image is highly enlarged. So here you can see object is placed at f1. Object is placed at f1. Image will form at infinity. So nature of the image is real and inverted. Real and inverted. Size of the image is highly enlarged. 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 Highly enlarged. So now you are going to the next one, sixth case, very very important case. 3 marks, 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 very very important, 3 marks. For 3 marks this question will come, very very important. So I am taking the optic center f1, 2f1, f2, 2f2. So 2f2, object is placed between f1 and o. Object is placed between f1 and o. Object is placed between f1 and o. F1 and o. Bone is nothing but optic center. One light ray I am taking, so it passes through focus. Another light ray I am taking like this. It passes through optic center. If you are extending this light rays, those light rays, image will form. So everybody listen, image will form behind the same side of the lens. Very, very important for 3 marks. 3 marks question. Very important for 3 marks question. Object is placed between F and O. Image will form. Image will form same side of the object. Nature, virtual and erect. Virtual, erect and enlarge. Virtual, erect and enlarge. Virtual, erect and enlarge. Object, 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 object. Object, 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 place, 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 place. Object is placed, 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 object is placed between F1 and O. Image will form same side of the object. What is the nature of the image? What is the nature of image? Virtual, erect, enlarge. Virtual, erect, enlarge. Object is placed between F1 and O. Image will form same side of the object. Nature of the image. Virtual, erect. Virtual, erect. Virtual, erect. And enlarge. Virtual, erect and enlarge. Virtual, erect and enlarge. Virtual, erect and enlarged. Right? Yes. So I hope it is very clear. Coming to the next one. Next one. So concave lens image formations. Concave lens image formations. Only 2 cases are there. Concave lens image formations. Only 2 cases are there. We will see now. Concave image formations. Only 2 cases are there. Concave lens image formations. Only 2 are there. One is object is placed at infinity. One is object is placed at infinity. One is object is placed at infinity. So optic center here. F1 to F1. F2 to F2. So object is placed at infinity. So one light ray I am taking like this. After refraction, those light rays will move away from the principal axis. So if you are extending those light rays, the image will form at focus. Image will form at F1. What is the nature of the image? Virtual, erect. Virtual, erect. Virtual, erect and diminished, highly diminished. Virtual, erect and highly diminished. Virtual, erect and highly diminished. And the first one, convex. This is the concave lens. Concave lens. Concave lens. So second one, if you are taking the object, so I am considering the object. So optic center, F1, 2F1, F2, 2F2. So object is placed anywhere between optic center and infinity. So one light I am taking. So it reflects back. So another light is passing through optic center. If you are extending this light ray, the image will form between F1 and O. Object. Okay, so this is the image formations. Image formations. So once again, come on. So very important. Very important. So image will form, but intensity will reduce. Image will form, but intensity reduce. If half of the lens is covered, okay, so still image will form, but so half of the intensity of the image will reduce. So previously how much intensity is there, how much brightness. So intensity nothing but when your mobile, if you are increasing brightness or reducing brightness, it depends. So here also, so intensity may decrease but same. So next one, Vidhan. So I am telling to you only. So full image will form, but so complete intensity may reduce. That's enough. Intensity reduce, but still it will form image. Or even half of the lens is covered with the black paper. Next one we are going to the next one. Next one we are going to the, so length formula 1 by f equal to 1 by f equal to 1 by b minus 1 by u. Magnification equal to height of the image by height of the object. That is nothing but so height of the object. So if you are taking magnification, height of the image, height of the object, that is nothing but v by u. Okay now, so plus 1 we can take for length, and here power of length, reciprocal of focal length, the degree of converging of diverging of length achieved is known as power of length. The degree of converging or diverging of length achieved is known as power of length. Power of length is positive for convex lens. Power of lens is negative for concave lens. Power of lens is positive for convex lens. Power of lens is negative for concave lens. I hope it is very clear to you all. So that is about power of lens. That's enough. So this is about topic. So if you like this video, please do like, share, and subscribe to Student the Brand. So again, 6 o'clock today and 9 p.m. So again classes will be there. Today 6 p.m. and 9 p.m. today only. Every day it will be 11 a.m., 3 p.m. And 6 p.m. and 9 p.m. So these are the class timings, live class timings. So come and join to the class. If you like this video, please do like, share, and subscribe to Student the Brand. And so give a like if you like this class. So until then, thank you.